An interrupt is a request from a peripheral to the processor to temporarily suspend the currently executing code in order to handle the event that caused the interrupt. After accepting the request, the processor saves its state and executes a function named an interrupt handler or interrupt service routine, shortly ISR. Interrupts are usually signaled by peripherals when they have some data to process. Often, peripheral devices do not send an interrupt signal directly to the processor, but through a special module called an interrupt controller. An interrupt controller is the unit that collects requests from various peripheral devices. It prioritizes the peripherals to ensure that the more important requests are handled first. The interrupt signal comes asynchronously, which means that it can come during the execution of the instruction. Usually, the processor finishes this instruction and then calls the interrupt handler. To be able to handle interrupts, the processor must implement the mechanism of storing the address of the next instruction to be executed in the interrupted code. Some processors use the stack, while some use a special register to store the returning address. The latter approach requires software support for nested interrupts. The picture shows the method with the use of the stack. After finishing the interrupt subroutine, processor uses the returning address to return program control back to the interrupted code. Different code should be executed when the interrupt is signaled by a network controller and a different code if the source of an interrupt is a timer. To call the appropriate handler, the processor must recognize the source of the interrupt. The information on the interrupt source is provided to the processor by the interrupt controller or directly by the peripheral. We can distinguish some methods of calling a proper ISR for incoming interrupts. Fixed method, used mainly in microcontrollers. Every interrupt handler has its own fixed starting address. Vectored method, used in microprocessors. There is one interrupt pin. The peripheral sends the address of the handler through the data bus. Indexed method, also used in microprocessors. The peripheral sends an interrupt number. The number is used as the index in the table of handlers' addresses. In modern processors, interrupts can be signaled with the message signaled interrupt mechanism. While the hardware needs to indicate the interrupt, it exchanges special messages through the chipset to a previously assigned memory address. Interrupts can be enabled or disabled. Disabling interrupts is often used for time-critical code to ensure the shortest possible execution time. Interrupts which can be disabled are named maskable interrupts. They can be disabled with the corresponding flag in the control register. In microcontrollers, there are separate bits for different interrupts. If an interrupt cannot be disabled, is named a non-maskable interrupt. Such interrupts are implemented for critical situations like memory failure, power down, or critical hardware errors. Non-maskable interrupts are often signaled with a special input pin called NMI. In some processors, it is possible to signal the interrupt by executing special instructions. They are named software interrupts and can be used to test interrupt handlers. In some operating systems, like DOS and Linux, software interrupts are used to implement the mechanism of calling system functions. Another group of interrupts, signaled by the processor itself, are internal interrupts. They aren't signaled with special instructions, but rather in some specific situations during normal program execution. They are in general called exceptions and can be divided into three groups: faults, traps, and aborts. A fault is generated by abnormal behavior in some instructions, like for example dividing by 0. Some exceptions are not really faults, but are used by the operating system to perform its normal operations, like handling the paging mechanism. A trap is intentionally initiated by the programmer for transferring control to a handler routine, for example for debugging. An abort is generated while detecting some serious errors in a program or computer behavior. It is usually unrecoverable, so it leads to a computer restart.